afternoon, everybody. My name is Maria Jose, and my experiment is called Operation and Investigation of Magnetism. Our question is, what is the effect produced by magnetism and how do these effects matter? So, our purpose is to determine how much force is exerted by magnetism on objects. Our hypothesis is through the use of magnets, we will be able to observe the magnetic forces by which magnetism is exerted, in addition to checking its attractive force. So first, we're going to present our materials. One magnet, coins of different size, a small wooden board, 4 aluminum cans, it can be soda, and a straw, and a clip of various size. So first we're going to present the procedures and pictures about the procedure. Use the 4 soda cans to form the base, 2 on each side, like this. Place the wooden board on the base. Then we place the magnet on the board. Under the table in the position of the magnet, we will place the coins one at a time, forming a row. To where we will notice that the magnetic force exerted by the magnet on the coins begins to weaken, and no more coins can adhere to the column of the table. In order to check the force of attraction, we will carry out several tests. When the column of coins is formed, we will carefully slide the magnet on the surface of the wooden board. Blow the coins with a straw so that they rotate without falling. We will carry out the same procedure with the clips. So we're going to start. So first we're going to put one coin under the magnet. Then another coin here. Then another one, and it only can carry 1, 2, 3, 4, 5, 6 coins. It seems like levitation, right? So we're going to do the same with the clips. One clips under the magnet, another one, and another one. Okay. It can carry 1, 2, 3, 4, 5 clips. Very interesting, right? We're going to now we're going to move the magnet around the table to see if it can fall. It can fall. It's very slowly. Jesus. Okay. It can only carry now 5 coins. So very slowly. Oh no, I think it's gonna fall. The coins are gonna fall. See? It's very strong and weak at the same time, but it's very strong. So now we're going to use our straw to blow the coins and see if it can fall or it can fall or it stay like this way. Oh, it turns around. So the coins that is more weak, it can turn, but like the first one, it can fall. So So the weakest are these two and this, because this clip is not big, so it's not very strong. Okay, so also we're going to see our results. We were able to determine that using the wooden board between the magnet, coins, and the paper clips always generates magnetism, as we were placing the magnet directly on the coins and paper clips. When we slide the magnet over the table, we observe that both of the column of coins and the clips stay together. But if we exert a sudden force, we weaken their magnetic field and they manage to fall. We identify the different variables. Our independent variable. If the wooden plank causes any type of bone distortion to interrupt the direction of the magnetism or its force of attraction. Our no variable, which is the use of magnets to absorb the magnetic force and generate biomagnetism. So our conclusion is ferromagnetic materials such as coins, paper clips, align their magnetic or magnetic domain to an external magnetic field in a such a way that they can become magnets capable of attracting other ferromagnetic objects, thereby extending the magnet's range, like we see right here, that they can stay very very strong, but when you blow with a strong, it can be feel very weak. So the magnetic field tends to get weaker as the distance from the main magnet increases. That's why it is possible to collect an infinite number of coins or paper clips in this case, like we see with these two, with this one, that it can fall very fast instead of the others, because they are near the magnet and they feel very strong. But like this little clip is so like away from the magnet, so it cannot be an attraction like this. Okay, so what we learned? We learned to know the forces that are produced through magnetism that are of attraction or repulsion of materials. Well, that was everything. I hope you like it. And well, this was a very difficult but easier experiment at the same time for me, but it's very funny. So, goodbye.